Hey viewers! What is the first thing that comes to your mind when you see something? Well, the name of that something. Let's take a look at this and think. The first thing that should come to our mind is Newton, because it is in Newton's cradle.
We are here with a drop of elixir of science. Talking about one of the mind-boggling discoveries mankind made. So let's drink it together.
So, Isaac Newton, as we know, invented physics, and all of the science depends on physics.
Newton did not invent physics. Physics was already there and we don't know who invented it.
Well, Newton certainly built upon the work of others, but it was the publication of these three laws of motion and theory of gravity more than 300 years ago that set science off the road. That has led to spaceflight, lasers, atomic energy, genetic engineering, and an understanding of chemistry and all the rest.
Yes, that's right. For 200 years, Newtonian physics reigned supreme.
And Newtonian physics is also known as classical physics. He came up only with those classical ideas. But even in Newton's work, 3 centuries ago, there were already signs of changes that were yet to come from his investigations on the nature of light. What do you think Newton realized about the behavior of solid objects?
He realized that our everyday experiences of behavior of objects may be misleading, and that an object, a particle free from any outside influences, must behave very differently from such a particle on the surface of Earth. Here on Earth, if we start pushing a pen, it stops after a while if we don't apply any force further. So you may ask, why don't objects like planets or the moon stop moving in their orbit? Is there something pushing them? Well, not at all. This is Newton's first law. Every object stays at rest or moves with a constant velocity unless an outside force acts on it. The second law tells us how much effect the force a push has on an object. A force changes the velocity of the object, and a change in velocity is called acceleration. If you divide the force by the mass of the object the force is acting upon, the result is the acceleration produced on that body by that force. Usually, the second law is expressed slightly differently. Force equals mass times acceleration. And Newton's third law tells us something about how the object reacts to being pushed around. For every action, there is an equal and opposite reaction, and the example is a flying rocket.
These laws, together with Newton's law of gravity, explain the orbits of planets around the Sun and the Moon around the Earth. But they also had puzzling philosophical implications. According to Newton's laws, the behavior of a particle could be exactly predicted on the basis of its interactions with other particles and the forces acting on it. If it were ever possible to know the position and velocity of every particle in the universe, then it would be possible to predict with utter precision the future of every particle, and therefore the future of the universe. Did this mean that the universe ran like a clockwork, wound up and set in motion by the Creator down some utterly predictable path?
Newton's classical mechanics provided plenty of support for this deterministic view of the universe, a picture that left little place for human free will or chance.
But could it really be that we are all puppets following our own preset tracks through life with no real choice at all?